Let me give you a moment to copy the example down. Okay, so they want you to find the polar coordinates. Okay, find the polar coordinates of a point with these Cartesian coordinates, -1√3. So one thing that's important to mention is that polar coordinates, you can have a point and it can have an infinite number of polar coordinates. Okay, Cartesian coordinates are unique. Given an x, given a y, that'll locate a point in the xy plane, and only that point will have those Cartesian coordinates. But with polar coordinates, you can have an infinite number of polar coordinates. Okay, and it has to do with the angles. All right, so in this problem, we have the Cartesian coordinate, a point with Cartesian coordinates -1√3. So for part A, we want to find the polar coordinate where radius is greater than 0, and we're restricting theta to be between 0 and 2 pi. And then on part B, we're going to find a polar coordinate that locates that point, but the radius is negative. So what do you think would be very helpful in doing this problem? What do you think would be very, very helpful to have?
A graph.
That's right. Absolutely. That's right, Maria. That's right, Nathan. A sketch. So here we go on the next page. I'm going to draw a sketch. So for our solution, I plotted the point -1√3. -1√3 puts us right here in the second quadrant. And I'm labeling the plot as much as I can. So, you know, I got a radius of 2. Well, I want to be careful here. I mean, -1√3 is right here. But if you think of that right triangle, right? I mean, we have here, maybe I can put it in red. Right, we have this right triangle here. So this is from your trig days. Okay, right triangle. And it's a 30, 60, 90 degree triangle, right triangle. So the because x is because x is -1 and y is √3, the reference angle is going to be 60 degrees, or pi/3. Okay, and so the angle that, like if we want to think now in terms of polar coordinates, all right, well, to get to -1√3, I can move an angle of 2 pi/3, which is 120 degrees, and then move forward a radius of 2. And that gets me to the -1√3. So 2 and 2 pi/3 would be be a polar coordinate. Okay, give you a moment to copy here. Okay, so, but now we want another polar coordinate with a negative radius. Well, if we go, if we rotate 120 degrees and then do 180 degrees more, that gets us to 300 degrees. That's what 5 pi/3 equals, 300 degrees. And from that angle, if we move backwards a radius of 2, that would be a radius then of -2, right? That also gets us to the point -1√3. So this is a nice example for polar coordinates, and I tried to label a lot of things on the diagram to help you get a feel. So this means there are infinite polar coordinates for a point. Here are like some other polar coordinates that would work for the Cartesian coordinate of -1√3. Okay. So you can always like do a revolution forward or backward, or 2 revolutions forward or backward, and change the angle, you know. But well, the angle would be different, but you arrive at the same place. So, you know, 2 pi/3, 2 8 pi/3, 2 -4 pi/3. All of these polar coordinates here are take you to the same point. And that's why in the example they restrict the angle theta. They notice they said in both A and B that theta is between 0 and 2 pi. They do that because they know that you can have an infinite number of answers. Are there any questions? Who's feeling good? Who's feeling good so far with polar coordinates? Okay, good, Renaud. Good, Tal. Good. Good, Jacob. Are there any questions at all? All right, well, give me a thumbs up when you're ready. I want to do one more example with you. Give me a thumbs up when you feel ready. All right, Maria's good. Abhidara's good. Tall's good, excellent. These problems, I find it very helpful to draw a picture. Very helpful. Iker, are you comfortable with the material? V, how about you? Are you comfortable? Okay, so I'm calling out some names here. V's here, good. Very good, V. Jazi, question? Jazi's comfortable, all right. All right, well, let's go to the next example. Let's go to the next example here. Okay, let's do another one. Now for this one, we're gonna work with, this here is the Cartesian coordinate 1, -3, like one of those friendly Cartesian coordinates that you remember from trig. Is that friendly or a little, Nathan? What? So oh, go ahead, go ahead.
I was just thinking about a question for the previous problem.
Oh, okay.
Can we answer it in degrees?
No, must be in radians. WebAssign will want the answer in radians, and it doesn't want decimals. Now, I want to be careful. It wants exact answers. So it doesn't want it doesn't want 60, well, it doesn't want degrees, but like pi/3, it doesn't want doesn't want the decimal. It wants you to type in pi divided by 3. Very good question, Nathan.
Okay, thanks.
Okay. Okay. So this is an example where we have a point, Cartesian coordinate, that's not like one of the friendly points, like what I don't want to say it's not friendly, but like those, like when you have like some Cartesian coordinates, like the previous example, you can figure out the angles right away. But 1, -3, I don't think we have an angle like 30 degrees, 60 degrees, 90 degrees, or any multiple of those angles that's going to work here. But that doesn't mean we can't do the problem. So it's the same kind of setup as the last problem. Same kind of setup. We have, we want to find a polar coordinate where the radius is greater than 0 and the angle is between 0 and 2 pi, and when the radius is less than 0 and the angle is between 0 and 2 pi. They have to restrict theta so that you see like, Nathan, for instance, might put in one angle and Leping might put in a different angle, Polar coordinates can have infinite number of answers. So they restrict the angle theta so that it's looking then for normally one answer. So what's the best way to begin this problem? Let's say this one on your final exam. Draw a graph. Draw a graph. And so, okay, we'll do that. So, all right, I'm going to let you copy this picture up here. Okay, let me give you a moment to copy it, and then we'll talk about it. Okay. I will say right now that the point 1, -3 is here. This is, you notice I put an X and Y above that, so you know it's a Cartesian coordinate. And again, we're always thinking in trigonometry of drawing those right triangles. So this is the right triangle. Guess I can talk about it a little bit. And with any right triangle, you always want to know the hypotenuse. Well, 1 squared plus -3 squared is 10. So the hypotenuse is square root of 10. And what I've done here is, as always in trigonometry, your reference angle is important. So, you know, this is your reference angle right here, right? That's your reference angle right there. Okay, I can. Here's the reference angle. Okay. And well, so all, you know, what is that reference angle? Well, I have there the tangent or the arctangent of -3/1. Why is that? Well, if this reference angle, let's call it alpha. Let's say that's alpha, okay? The tangent of alpha would equal y over x. So the tangent of alpha is equal to -3/1. Well, that means then that alpha is equal to the arctangent. Alpha equals the arctangent of -3/1, which is the arctangent of -3. So if we want an angle theta that's between 0 and 2 pi, well, all right, well, let's think about this. So so what we do is, you know, we would do this angle here. And what's that angle? Well, a full revolution is 2 pi. But this angle would be pi plus the arctangent of -3. Okay, this angle here is pi plus the arctangent of -3, because the arctangent of -3 is actually a negative number. So it's a negative angle. It's going to be this angle here, this reference angle. But the arctangent of -3 is equal to negative times the arctangent of 3, because the tangent is an odd function, right? Tangent is an odd function. So the arctangent of -3 would be negative times the arctangent of 3. And so that's going to give you the answer to part A, √10, and then 2 pi minus the arctangent of 3. And that's what WebAssign's going to want, class. It's not going to accept a decimal. It's going to want an exact answer. Okay.
Will it accept arctan, or do you have to type in tangent -1?
I think it'll accept both, Maria. I think it will accept
just checking.
both. But I'll tell you what, you're going to find out in the homework. But I think in the homework, I think it uses tangent -1. But you could try the arctan. Okay, very good question. And then for the negative radius, I'm going to use this angle here. Which would be the arctangent of -3 plus 180 degrees, which is pi. So pi minus the arctangent of 3. And then I go backwards, square root of 10. Okay. So I thought you should see an example like that because you'll see it in your homework. You could see it on the test, on the final exam. You know, we have to be prepared in life to deal with problems that don't have like, quote, nice answers. You know what I mean? But if we stick to the fundamentals, we'll be fine. Okay, are there any questions? Okay, I'll stop the recording. Wait, hold on. Let's see, Renaud. Hold on, Renaud. Why it's 2 pi minus. Okay. So, okay. So you agree that this angle here, this reference angle here, you're in agreement that's the arctangent of -3, right? Okay. So that's an angle. That's an angle. And you know, if we sort of thought like a little, maybe outside the box a little bit, if we just, you know, okay, if we were to draw this angle alpha, that's a negative angle, right? That angle alpha is a negative angle. All right, we want a positive angle. This would be the positive angle. So wouldn't that angle be equal to 2 pi plus alpha? Okay. So what we have all right, so what we have here in our pictures, we have 2 pi plus the arctangent of -3. And that's an acceptable answer. But it is possible WebAssign might want you to write that as 2 pi minus the arctangent of +3. Because the arctangent of -3 is the same as negative times the arctangent of +3. Because because of the properties of the tangent being an odd function. Okay, excellent, excellent. Good question, good question. Okay, anything else? Any other good questions? The reason, Marcus, we have to use the arctangent of -3 is we don't know what the angle is. This red angle here, this reference angle here, this red reference angle. Okay, the arctangent of the arctangent of -3, we don't know what angle that is. Okay, it's kind of like if you think like hold on here. If you have like, you know, the tangent, let's say this the right way. If you have the tangent of pi over 3, right? The tangent of 60 degrees is √3/2, right? So the arctangent then of √3/2 One moment. Hold on. One moment. One moment. Hold on. One moment. No, I don't have that right. I don't have that right. Let me try this again. That wasn't right. But let's pick something simple, okay? What's the tangent of pi over 4? I mean, the other thing was fine too. You know, the tangent of pi over 3 is root 3 over 1. Okay, let's just go pi over 4. All right, tangent of pi over 4 equals 1, right? So what's the arc tangent of 1 equal to? What's the arc tangent of 1? Pi over 4. And that's because, you know, the pi over 4 is a nice value, you know, and the 1 is a nice value. But -3, there's no nice value for that, you see. The arctangent of -3 is not equal to any one of our nice angles. So all I can do is leave that as arctangent of -3. Is that okay, Marcus? Okay, excellent, excellent. Yes, Nathan.
So I have a question about using 2 pi or pi minus some value. Why did we choose to do that rather than, say, pi over 2 plus some angle? Or
Well, it has to do with so like if you're on here, if this is your reference angle right here, but you don't want that angle, you want this blue angle here. You want this blue angle. See that? I gotta hold on.
yeah, I think I understand what we're doing,
Okay.
but I'm wondering, you know, is WebAssign going to accept an answer that has, you know, a different representation using, instead of pi minus inverse tangent, maybe it would be,
Or 2 pi minus inverse tangent, you mean?
yeah.
No, that's what it'll want. That's the only right answer. That's what it will want. It is the right answer. Because, but remember, your question's a good one. Remember what they're doing. I see where you're coming. You see, they're restricting theta. They're restricting your angle to be between 0 and 2 pi. They're doing that on purpose because it's looking for one answer out of an infinite number of answers. So many, like infinite number of angles would work, but it wants just one angle. And so they're saying make it between 0 and 2 pi. Okay, does that make sense?
Yeah, I'm still trying to get a little clarification because I don't understand why it can't be pi over 2 plus some extra theta as opposed to, you know, 1 pi minus some piece of theta.
If you have, so let's say this is your angle alpha, right? Let's say that's your reference angle, okay? The only other angle, another angle that'll get you to the same spot is this angle. Now this angle, and by the way, alpha is negative. Alpha is less than 0 here, let's say. So this angle here, this red angle would be 2 pi plus negative alpha. 2 pi plus
Yeah, I
negative alpha.
understand.
That's it. That's all there is to it. Nothing more. I'll tell you what. Let me go ahead and we'll talk. We'll let folks get working here on this assignment. I'm going to give folks 15 minutes, and then but you and I we can talk. We can talk. Okay, we'll talk like right while people are working on this assignment. Are you okay if we talk a little bit?
Yeah, that's fine. We can proceed.
Let's do that. Very good question, Nathan. All right, I'll stop the recording.